Hello class, Mr. Smith here. One of the coordinate systems that you need to be really familiar with is polar coordinates. And so typically we're only going to worry about two dimensions. A lot of the motion that we deal with is just two-dimensional. So we can have an x, y coordinate system. This is our good old Cartesian coordinate system just collapsed into two dimensions. But let's say we have a point out here. Okay, and we know that it has some x, y coordinate in that Cartesian space, but now we want to define it in terms of some other variables. What could I use? Well, one possibility is how far are you from the origin? Okay, and that we would typically use lowercase r, and that may be enough, but not quite really, because if I just told you r, you could be anywhere on the circle of that radius r. So we need one more variable, and the variable that we're going to use is theta. What is the orientation of this line with respect to the x-axis? So then these are called polar coordinates, r and theta, polar coordinates. To be technically correct, the three coordinate systems that you need to worry about as you go further in physics and science and math are the Cartesian coordinate system, the cylindrical coordinate system, and then the spherical coordinate system. And this one would correlate more with the spherical. But in two dimensions we call it polar. So what's your angle relative to the x-axis, and what's your distance from the origin? Okay, now you can see what happens. There's a nice little relationship between these things. So if I draw that line again, okay, and then I go ahead and complete the triangle, and I make this a right angle, and then this is theta, then that xy coordinate up there corresponds to what? Corresponds to moving over an x by that amount, and then moving up a y by that amount. And so now we have a nice little triangle, and we know how to deal with triangles. Good old SOHCAHTOA. What is the cosine of theta? Somebody shout it out. Raise your hand and shout it out. What is the cosine of theta in this picture?
X over R.
X over. Cosine theta equals x over r. Cosine theta is adjacent over hypotenuse. What about sine of theta? Who knows what sine of theta is?
Y over R.
Why not? Absolutely. And then finally, tangent of theta is going to be y over x. And so these are the very nice trig relationships for this triangle, but we also have Pythagoras, who told us that the hypotenuse of a right triangle is the square root of the sum of the squares of the other two sides. And so all those things describe how r and theta relate to our Cartesian coordinates x and y. And so now there's also a very, very nice sign convention we have, which is the following. Thetas that are going up are bigger than 0. And thetas that are going the other way are less than 0, okay? Namely, if you are rotating counterclockwise, that's positive. And if you're rotating clockwise, that's negative. Now, this is just a convention we're not always going to use. But that is the typical convention for these signs, and that's polar coordinates.